Quadratic vertex form, pre-calculus, pre-college math. The previous video, we learned how to turn ABC quadratics into our vertex form quadratics. And all we really want to do now is learn how to translate that information into a vertex, an axis of symmetry, and find the roots in simplest form. All of which we've actually done a little bit of already, so there's really nothing too new here. Um, and I think all these problems are going to be given to you in this vertex form. I may change a couple of them where you have to first convert it into this and then answer these questions. But for now, just getting used to reading this form, we're going to give it to you like this just to make that transition a little easier for you. First, the vertex, and this again was mentioned in the previous video, that the vertex is the opposite sign here and the proper sign here. The reason why it's the opposite here is because in transformation language, this means the opposite direction of what you think. Like minus here would actually mean right, which would be to the positive side, and a positive number here would mean left, which is to the negative side of the x-axis, and so on. But k is what it is. Axis of symmetry is simply x equals this number. Again, opposite sign of what you see in there. And then the roots in simplest form, solving for x, that's the one that's going to require a little bit of algebra. And that's the one where we're going to kind of finish the completing the square step that we stopped in the previous video. So let me show you. Here's an example. This is in our vertex form already. The vertex would be positive 3, negative 4, right? The opposite sign of what's inside the parentheses, and then the proper sign here, meaning keep that sign as negative. Axis of symmetry is just x equals 3. Super easy. It's the opposite sign in here, or you can think of it as the number here. The most important thing is the x equals in front of it. A lot of people, when the question's given, what's the axis of symmetry, they say 3. 3 is a number. X equals 3 is a vertical line on the graph crossing at 3. Like this is the point 3 on the x-axis, and this is the line x equals 3. So make sure you have the x equals in front of it, otherwise it's not really as valid. Roots in simplest form. Okay, so what we do is we take the x minus 3 squared minus 4, and we set it equal to 0. Then we move that constant back over, so x minus 3 squared equals 4. And what we were doing yesterday is we turned ABCs into this using the completing square, and then we brought the 4 back. Well, now we're putting it back on the other side, and we're going to continue that completing the square process of doing the square root on both sides, get x minus 3 equals plus or minus the square root of 4, which is 2. It's actually a rational one. And then adding 3 will be x equals 3 plus or minus 2. And typically we leave it like that, but because 2 is not a radical, I can actually do 3 plus 2 is 5, and 3 minus 2 is 1. But your answers are typically going to be 3 plus or minus some radical type thing. Let's do one more example. All right, the vertex, now this one has a term, a number in the front. That does not impact the vertex or the axis of symmetry. So that's still just involving opposite sign here, proper sign here. So vertex would be negative 5, negative 8, because this means left 5, down 8. Axis of symmetry is x equals, don't forget the x equals, negative 5. The roots in simplest form, so 2 parentheses x plus 5 squared minus 8 equals 0. And first thing I do is move the constant over. So 2 parentheses x plus 5 squared, set it equal to 8. And then before I do square root with the plus or minus and stuff like that, if you have an a term here, that needs to move to the other side. So you're going to be dividing by 2. Dividing by 2. And this is going to actually end up being a 4 again. I didn't realize this problem turned out to be so similar to the one before. So x plus 5 squared equals 4. This isn't going to come out to always be, it might just remain a fraction sometimes. It might come out to be an irrational number. This is just kind of a coincidence that it worked out to be a 4, which was also the case here. I wasn't aware that was going to happen. I would have changed that number up to make it a little bit harder. Because now when I do the square root of both sides, what's going to happen is I'm going to have x plus 5 equals plus or minus 2 again. But like I said, most of your problems are going to be stuff like rad 2. But this one happens to work out. So then you can move that negative 5 over to maybe a negative 5 in front of the plus or minus 2. And again, I might as well simplify this to be negative 7, and negative 5 plus 2 is negative 3. But that's not going to happen that often. It just, of course, happened in the only two examples I was planning on giving you. If I were to look ahead here, yeah, this one's not going to work out that way, because I can just see that when I'm going to end up adding 9 and dividing 4, and it's going to be 4 over 9. And so you're going to end up with, well, it actually is going to be rational here, but it's going to be a fraction, so it's no big deal. And then this one's definitely not going to be rational. You end up with a radical left in that one. So just know that when you do the square root of both sides, this particular two examples, we had a square that we did the square root of, and have it to both be 4 both times. That's not going to always be the case, but we'll certainly practice this in class tomorrow. So, short video today.